All right, so we're going to go over questions 87 and 89 from the homework from last night. Both of them have the same concept, and that is it's a 4-termed polynomial, which means we want to try that grouping pattern, but it doesn't seem to work. When we look at the two, splitting it up into 2 pieces, they have nothing in common that we can factor out. But remember, you can move terms around in a polynomial, right? You can regroup them. So what if we rewrote this and I grouped this 9b squared y with this one? Would those have something in common? Okay. Now, I also could have grouped the negative 16x here with it because they still would have had an x in common. That would have worked as well. All right. But simply rearranging them so that you're finding something they do have in common is going to help. Because I've moved the 9b squared y into that second position, the other pieces I have left over are the negative 16y and the negative 16x. Okay, and those have a negative 16 in common, so that will work as well. Now if we try that grouping pattern, in this first chunk, we have a 9b squared that's common. When we factor it out, we're left with the x plus y. Are we okay with that part? Okay. In the second set here, what's common? So if we pull out a negative 16, factor that out, we have a y plus x left. Okay, because we took the negative out. Now, is x plus y and y plus x the same? Is 2 plus 3 the same as 3 plus 2? Yes. So we do have a matching factor. That's going to come out as our common factor, our GCF that we've pulled out. And the pieces that we have left over are the 9b squared and the negative 16. Okay. Can that be factored more? 9b squared minus 16 is what pattern? Difference of squares. Okay. So we're going to end up with x plus y. The 9b squared minus 16 would factor into 3b plus 4 and 3b minus 4. All right, so that's the complete factorization. All right, question 89. Again, similar, we do have to do some rearranging of the terms. All right, so what's one way that we could rearrange those terms? Which things could we group together? Okay, the pieces that have the x squareds. All right, so I'm going to rearrange this. I'm going to put this negative 2x squared next. And then I've got a negative 16y and a positive 32 left. Looking at the first half of it, I can pull that x squared out. It leaves me with y minus 2. And then what am I pulling out of the second set? Yeah, you want to pull the negative 16 out. That leaves you a positive y, and it turns this 32 into a negative 2. And now you have that common factor of y minus 2. All right, so y minus 2 is the common one, and what's left is the x squared minus 16, which again is a difference of squares. And it can be factored down into x plus 4, x minus 4. Any other questions from homework? All right, let's move on to section 6. We're going to spend 3 days on this. We're looking at rational expressions. We've reviewed a whole bunch of different factoring techniques, and those will be used in what we're going to do in section P.6. So a rational expression is defined as the quotient of 2 polynomials, right? Basically, it's an algebraic expression, an algebraic fraction. All right? So we have some kind of polynomial in the numerator, we have some kind of polynomial in the denominator. It could be as basic as just a monomial, like that 4. It could be a binomial, trinomial, as long as it's some kind of polynomial. Okay? Our domain is defined as the set of all real numbers for which the expression is defined. In other words, the set of numbers that work when we plug them in for x. Okay? The numbers that we can use for x, that's our domain. There are a couple places that we'll look at over the course of this year where we have to restrict the domain, and one of them is because of the denominator. When we've created a fraction, we've created a denominator. And denominators can't be 0. We can't divide by 0. So that's the issue with what we're going to look at today with those domain restrictions. We have to look at what would create a 0 in the denominator and restrict that out. Okay? All right, so first step is to make sure things are factored. And then we're going to look just in these first two examples here at what domain restrictions we would have. Okay, so x plus 5, it can't be factored anymore. What would create a 0? What value would I plug in for x that would turn that denominator to 0? All right, so -5 is the domain restriction. So we can either say the domain is all real numbers except -5, or we can just say x can't be -5. Okay, I'm okay with either way of saying it. For the second one, in order to figure out what those zeros are, we do have to factor this trinomial. How does x squared minus 5x minus 14 factor? Okay, I heard x minus 7, x plus 2. So what would make this first factor become 0? A 7. What makes the second factor become 0? So those are the two values that I'm going to have to restrict out of my domain. Okay, I can use any x except 7 or -2. Okay? All right. So what we're going to do today, we're going to simplify rational expressions. We're going to multiply them. We're going to divide them. In order to do all of those things, we have to have everything factored. So step 1 is make sure every numerator and denominator is factored. Okay? Our second step then is to reduce out the common things. Now, what I mean by reducing out the common factors, if I just gave you a basic fraction like 5/15, what would you reduce that to? 1/3. And why are we reducing it to 1/3? What is it that we're dividing out? We're taking a 5 out of each. So if we really want to think about the steps you're doing, and by this point in your career in school, you figured out how to do that in your head, right? But what we're really doing is we're saying, I'm going to factor the numerator and denominator, and notice that there's a common 5 that I can reduce out. That's what you're doing when you reduce a fraction. So what we have to do with algebraic ones is we have to make sure we have everything factored, and we really find those factors that match, that we can reduce out. Okay? So for our first one here, what can we do in the numerator? All right, if we pull out an x squared, we'd have an x plus 3 left. Are we okay with that step? All right, now, it says to simplify the rational expression and state excluded values. You want to make sure you state the excluded values before you start crossing things out. Okay, so our process is going to be factor everything first, identify the domain, and then reduce. Because it's common to reduce out factors in the numerator and denominator and forget to put those domain restrictions in. All right, so looking at the denominator, we have an x plus 3. What do we say x can't be? Can't be -3, because that would create a 0. Now we can reduce out. Notice that what we are reducing out is this whole quantity of x plus 3. I want to be very clear that I'm not taking an x out and a 3 out separately. I'm taking the whole quantity x plus 3 with that matching quantity. Okay? You cannot take individual terms. So the final reduced form of this is just the x squared with this restriction that x can't be negative 3. So even though that restriction kind of disappears in my final answer, it still has to be considered because it was there originally. All right, part B. If we were to factor the numerator, what's that pattern? X squared minus 1. Difference of squares, okay? Factors into x plus 1, x minus 1. How about denominator? Okay, it's actually one of those perfect square trinomials where we have two identical factors. All right, looking at restrictions. Denominator only. What can x not be? All right, so we're going to say x can't be negative 1. And then I look to restrict, or to reduce. I can reduce one of these x plus 1s with one of those. All right, it still leaves me one. It has to be a 1-for-1 reduction. Okay, so final answer would be x minus 1 over x plus 1. Questions about just the simplifying part? Okay. Going back to just a numerical example to refresh our memory on the steps. How many would look at this and say, I just have to multiply across? Can I do that? Can I multiply across? I can. The issue here is if we multiply across, we've created bigger numbers, right? And then we still have to try to reduce it. You're better off reducing first. And when we move on to the algebraic ones, you have to reduce first. You don't want to multiply a binomial and a trinomial together and then try to reduce it after that. All right? You want it in that factored form. All right. So, reducing. We can take a 4 out of the 4 and the 24. It leaves me a 1 and a 6. I can reduce the 5 and the 15 to 1 and 3. And now I multiply straight across. So 1 times 1 and 3 times 6. What is the extra step we have to do if it's division? Yeah, we actually have to multiply by reciprocal. All right, so I want you to think of this as 4/15 times 25/22. Go ahead and reduce and then multiply what's left over. All right, let's check what you did. What can you reduce out? Okay, 25 and 15, we can take 5s out. What else? Take 2s out of the 4 and the 22. So, final answer is what? 10 over 33. Okay, so we're just going to shift now to doing that same process with algebraic fractions. Okay, your steps. Factor. I'm going to say it 50 million times between now and your test next week. Factor, factor, factor. You have to factor first. Then look at your domain. All right, are there any numbers that you have to restrict out? Then look at reducing. And then whatever's left over, multiply, divide those pieces. Okay? So, for the first one, can I factor x minus 7 or x minus 1 in that first fraction? All right, so we're going to leave it, x minus 7 divided by x minus 1. We're multiplying, though. There is some factoring I can do here. Okay, x plus 1, x minus 1, that's that difference of squares pattern in the numerator. And denominator, what can we do? Good. Okay. Step 2 is to find domain restrictions before we start crossing stuff out. So what can we not use? X can't be a positive 1 or 7. And remember that I'm looking for that in the denominator, right? So I looked at those two. Yes. For division? Yes, and we have a couple examples of that coming up. Notice that I'm not worried about the numerators at all. Okay? I'm just looking at denominators for restrictions. Then what can we reduce out? Okay? Good. So reduced answer for this would be x plus 1 over 3 with this restriction. All right? You have to state that as well. All right. Our second multiplication example, we have quite a bit of factoring to do. The x plus 3 is fine, but what's the denominator going to turn into? All right. Take a minute and go ahead and factor the second half of that. All right, checking our second fraction. How did you factor the numerator? Okay. And denominator? Good. All right, domain restrictions. Looking at all of my denominator pieces, what can x not be? 2 and negative 2. And you can put that down as just plus minus 2 if you want. Okay. And then on the second half here, it can't be a negative 3. All right. Reducing what we can. I see an x plus 3 that I can take out and an x plus 2. Anything else? So my final answer is going to have an x minus 3 as the numerator. It's going to have an x minus 2 and an x plus 3 for the denominator. And I'm fine with you just leaving it like that in factored form. You don't have to FOIL it out. Okay. All right. Our last two examples are the division ones. And we said we have to remember to flip it over, do the reciprocal, and then multiply. We're going to go ahead and write that down as we factor everything. So x squared minus 2x minus 8 would factor into what? Okay, x minus 4, x plus 2. Denominator x squared minus 9, that's that difference of squares pattern. Okay, and now instead of division, I'm going to multiply by the reciprocal. So x plus 3 becomes the numerator, and x minus 4 becomes the denominator. When you go to list domain restrictions, you now have 3 places you have to look. You have to look at all the denominators, all right, from that first one, any denominators in your second fraction, and also the numerator in the second one. Because that x plus 3 used to be a denominator. Okay? So you actually have to check all 3 of those places for restrictions. So what would we say? X can't be a negative 3 and a positive 3 from this first one, so plus minus 3. It also can't be a 4. And then when I look at the top, it can't be a negative 3. Now, I already have that one listed. I don't have to list it again, but I did have to check if it had been something different, I would include it in my domain restrictions. All right, reducing out what we can. I see an x plus 3 and an x minus 4. So my final answer would be x plus 2 divided by x minus 3. Yes?
Anything that was or is a denominator is a restriction?
Yes.
Or like has a restriction?
Yep.
But anything that's on the top wouldn't?
So if it's a division problem, we are looking at denominators here, and then we also have to consider that one because it turns into a denominator when we flip it.
Okay, so not the x.
So the very first numerator I don't have to worry about. So that never shows up as a denominator anywhere. Okay. I'm going to pause the recording. Go ahead and try this last one on your own. Check in with your table mates if you have problems. All right, checking our last one. Numerator should factor into x minus 1 times x minus 1. Denominator, we can pull an x out. It leaves me x squared plus 1, which doesn't factor anymore. If it had been x squared minus 1, it would be that difference of squares pattern. But there is no way to factor a sum. Second half here, we're going to flip over. I'm going to pull a 3 out of this and leaves me x squared plus 1. The numerator now becomes the denominator. It factors into x plus 2 and x minus 1. Do we agree on the factoring? All right. Domain restrictions. What can x not be here? 0. How about in here? If you think about it this way, for x squared plus 1 to turn into a 0, the x squared here would have to be a negative 1, right, to add with the 1. Is there any value that when I square it turns into a negative? So there's no x's that I have to worry about here, all right? Any x would be fine. I won't create a 0 in that portion of it. For this piece here, x can't be negative 2. For this one, x can't be a 1. I do look at this again, all right, because it was the denominator originally up here. But for the same reason that we had down here, there's no values that I have to restrict out. Okay? Then, reducing what we can. I see an x minus 1. I can take out this quantity x squared plus 1. Anything else? So I'm going to have a 3 times an x minus 1 for the numerator, and an x times an x plus 2 for the denominator. And again, you can just leave it in that factored form. All right. So for homework, you guys are going to do, starting page 86, 1 to 31 odds. Obviously, you have to show work. Okay. I do have a short formative quiz for you to do. So I'm going to get that passed out, have you do that first.